Expert at this. There, that sounds good. Welcome, Rudy. Welcome, Chuck.
Hello.
And thanks so much for coming. I'm doing this in a way that we can send this out to people to give them
Okay.
a bit of a wider idea of what on-grounding is all about and undergrounding and what's happening in California because I think you guys are ahead of the curve in a big way because of what you've been through as well. So, Rudy, can you give us a bit of a rundown of your role and especially to do with on grounding?
Well, let me just kind of set that. Yeah, let me kind of start from the beginning. So, I'm a utility engineer, 41 years in utility business, worked for several different utilities, grew up in Boston, Massachusetts, worked for one of the original utility in US called Boston Edison, was founded by Edison himself. Uh,
Yes, that's as original as it gets.
Yeah. So I started there in 1983 out of college. And my focus of area responsibility was actually the greater Boston, all the underground in an old city of Boston, very similar to Manhattan, New York, and San Francisco, and some of the Chicago, and some of these large cities that have highly congested, cities. Everything is undergrounded. So just fundamentally, there are two methods of providing distribution system. It's either overhead or underground. Now, there are two types of underground. It's what's called subsurface, means everything is below ground, including enclosures, transformer. That's what you're going to see in large cities, downtowns. And then you're going to start coming out to the suburbs, and it becomes an underground pad mount, meaning the equipment are in the boxes, in the green boxes, sitting on a pad, but all the cabling is below ground. Now, once you get further out into the rural areas, that's where they typically, this is general, of course, every utility's got different NEAs, but DNAs, but then they start going to what's called the overhead system. So they put poles and wires. Now, the cost of building the system are proportionally highest in the downtown where everything is below ground. Then it goes to pad mount, and then the cheapest distribution system to build is overhead. They all have pros and cons like anything in life. The nice thing with overhead is when something breaks, you most likely going to see it. Someone's going to call you and say this thing is bending or cracked or ripped or whatever. Um, they also at the same time, a lot of the utilities used what's called open wire for overhead construction. So the conductor that you see sitting on the pole is an exposed conductor. If the conductor comes in touch with the ground, and it could potentially have an arc, most likely will have an arc, and could, depending on what's underground, could cause a fire. If there's no
Yeah,
fuel, then the arc, it just arcs and then it relays out and the circuit becomes de-energized. Um, but
that's mostly what we have, by the way, here on the island.
And the key is these systems have been built in this in United States since late 1800s when they went from distributed generation that Edison created, loads went up, and then it become utilities, and then that's kind of they start building it. Now, a lot of the requirements haven't changed in many years. Majority of the rules, including National Electric Safety Code and some of the requirements by utilities, were developed sometimes between 60s and 70s. None
Yeah,
of it has been revisited. This is an old industry. They're not very, it's not their comfort zone to look at new inventions. They kind of go with what they have good experience with, and they have enough data that they're very confident how these things are going to perform. But
mm,
what's happening, and I, my last job, I was a director of asset management apparatus engineering. I was on a board of research for utility industry as part of NETRAC, National Electric and Electronic Research Committee. And one of the things that we are challenging, like I said, is that No, we're not open to this. And so I retired in 2020, and as my last role, I was responsible for developing requirements for fire risk reduction or fire resilient system design. But there's also this element of cost, right? So if you're focusing on reducing effect of external implication, which we are perfect right now in as far as a perfect storm. We have aging infrastructure, majority of the asset base across the US. Again, it's general. Some utilities have been better in managing them and proactively replacing things. Some have not. Based on the regulation, utilities only get payback when they make capital investment, not maintaining things. There is no benefit for them in that regards. So they prefer to do that. But we have an aging infrastructure, and due to the fact that we haven't really done a lot in the past 30 years, now the volume is more than we can handle. So they have to go based on a risk-based approach or some kind of a mathematical modeling, which doesn't always work because it's Murphy's Law. What you think didn't fail is not going to fail. That's the one that probably does fail. Um, we have various states in the US, how they managing the vegetation. Some do a better job than others. But California, for the most part, they start doing pasturing. So there's a lot of grass. There's a lot of dry grass over hot season. And then we have climate change, which are now introducing extremes that we've never seen before. In
Yes,
areas where a 50-year wind peak was 40 miles, we're getting 95 miles now. So
totally.
it's a perfect storm for bad things to happen.
Yeah. And
Now, if you happen to be in a location where you're hard to access, that becomes even a bigger risk. Because
yes,
one main thing is when bad things happen, if the emergency response team can get there quickly, they can mitigate and minimize the potential impact. But if you
yeah,
happen to be in the middle of nowhere, up in the mountain, 2 hours from any main road, well, guess what? By the time you get there, you've already got a huge wildfire going on.
yes.
Um, Now, so anyways, I'm gonna kind of get to the bottom of what I'm trying to get. So when I retired, I said, you know what? We have to change our mindset. What we've always done in the past may not work for the future.
Mm-hmm.
We need to build a system that is more or less affordable to build, but eliminate the risk of overhead system.
Mm-hmm.
So my goal was I came up with this invention called the ground level distribution system. I use a fire resilient material for casing of a concrete that I've used and come up with a formula for what is called a geopolymer. Geopolymer material have been used in the world for decades.
Mm.
In Egypt, the Persepolis, all of those structures that are still standing from 3,000 years ago were made with geopolymers. Portland cement just came about a few years, a few decades ago because they were cheap, but they're not recyclable. Geopolymer material is fully recyclable and,
Mm-hmm.
and very earth friendly.
And
Uh,
extruded,
yeah,
correct?
yeah. And it's basically synthetic rock. That's basically what. So it's stronger than Portland cement. And then what we do is we put our cable and the pipes inside of that, so it's protected. We're currently in the process of getting fully tested by a research entity called EPRI, Electric Power Research Institute, out of Palo Alto. Their lab is in Lenox, Massachusetts. We've just went through compaction, impaction test, and then next week they're going to be doing some current testing. Um,
I thought it
yeah,
might be helpful to put some of these images up.
yeah. Well, yeah, I can. I was going to share you the presentation, but anyhow, bottom line being here that the premise of the system is now one of the things that, as in my previous life, when folks decided to, okay, I'm going to spend the more money and take the overhead down and build on the ground. There are a number of challenges that I try to solve with my invention. When you have hard grounds, rock, granite, it's very, very expensive to excavate. So
Mm.
that's what there is. Now, other places is that where we have potentially contaminated soil or asbestos, the cost of digging up, cleaning that soil is prohibitive to build an underground. It becomes too expensive for them. Um, and then one of the other things that we did as a pilot is uh, there was an area. It's called Woodland. It's in the Palo Alto area. It's kind of a reservation, kind of a lot of nice vegetation, old redwood trees, and they wanted to underground the line. That area was an overhead supply, had several fires and several issues, hard to get to as far as restoration. So they wanted to underground it. There are 9 residents, that very nice homes in that area. Actually, the founder of Tesla, the CFO of FICA, I mean, very, high-end folks live in that area, and they're very fond of their area they live in. They were concerned that the roots of the trees would be damaged with the undergrounding system, and they wanted it to protect their natural habitat of their neighborhood. So we selected, so the utility decided, hey, we got this concept. This seems to be, kind of right fit for what we're trying to do here. And we built that system for them. Please, I used to be in academia, so I keep talking. Chuck, just kind of, just stop me if you got a question. Just kind of, uh, I want to
Oh, no,
share.
that's good. Thank you. Yeah, I actually have a lot of questions, but that was a really good introduction as to where you've used this. And
Yeah,
I hope,
I'll go through these and then I'll open it up to answer your question. Can you guys see my screen?
yeah, I can see it. Go ahead and finish, and then I'll ask
Okay.
questions.
So, there's two type of construction with GLDS. We call it ground level distribution system or minimum cable cover system. So it can be a bit underground, shallow underground. We do basically a 10-inch trench and we bury the system and then we put 6 inches of soil on it. Actually, 1 inch of soil and 4 inches of pavement. Where we do that is if there is water runoff issues, stormwater issues, if we're crossing driveways, we certainly don't want to have somebody have a huge bump on the road across their driveway. And I can share this information with you, but I want to really get into how this thing was. I kind of made this in my garage and I started, doing it, enhancing it, and ultimately we did a test at the lab where we installed the system. You can see me here, hands-on, putting in geopolymer, and we have what's called basalt mesh, which is basically more of a kind of a rebar thing that allows the concrete to stay together for a long time without breaking up, but also to add strength. And this could be installed to support pad mount construction. So you would basically install, instead of putting it in the underground, you just either lay it on the ground, right underground level, or you go shallow ground level. This is a picture of where we used it, the pilot. And we just, basically we want to make sure we have, if you're in the roadway, we want to make sure we have 90% compaction. So over time, the thing doesn't sink in, even though there is really no public or safety issue. But it's really about ensuring that we're offering a system that can compete with other asset systems that are being built in their longevity, and minimize any kind of extra things that they have to do. Once the site is compacted, now if we happen to be in a pasture area, then we don't need any compaction. What we do, we just leave sufficient slack on both ends of the termination, so that the system, if there was ever erosion of whatever, that would still stay intact and stay in service without causing any issues. Once that's set up, we set up the cable rail. And then we installed I'm sorry, we put the cable trays and then we put the cables inside with the pipe. They come together. It's called CIC, cable and conduit. See it on this big wheel here. And we put those in and we ziplock them to make sure they stay intact, because this pipe and cable tend to want to go back to the form that they're on that wheel. So what we got to do is we got to make sure they're anchored down. And then we install and we pour our geopolymer in there. Once we pour our geopolymer, we're basically good to go. We put the top cover on it. Now you basically have a minimum of 2 inches of concrete around the primary pipe, which is aligned with National Electric Safety Code requirement. Even though on the ground level it's not part of it, it's something that we need to work on getting accepted by them. But fundamentally, it meets the requirement that they have. Excuse me. And then once it's done, we basically anchor it down and ready to go. Now, what you see here is that minimum cable cover. This area is where the water, stormwater in this area flows from. So what we did is we did not want to block the water flow. We do actually have a design where every 200 feet, we go down a little bit for about 2 spans. These are 6-footers. And that will allow the natural flow of water in general. But if you have a heavy raining area that you know that there's going to be severe, storms, that's where the water runs off, then we try to prevent that from being blocked. And then ultimately, the stuff is anchored with different type of anchors, sizes, and heights and strengths, etc., depending on the type of soil, whether it's a hard ground, soft ground, very soft ground. We could use staples. These are 32-inch, 36-inch staples, 18-inch staple, 9-inch staple, 18-inch screws, 9-inch screws, etc. Okay, so now we're done.
We have very soft soil on Vashon in general. They call it Vashon till. So not in every area, but it's the predominant soil.
Yeah, we'll basically do a test, and then we'll make structural recommendations as far as what would make sense. If you have a soft soil that, also you need to drive over, that becomes a bit of more of a challenge, where potentially we would make sure that we would trench and not trench, but meaning that we would basically do what you see these guys doing here.
Yeah.
So what we did here, we cleaned up. You can see this is about a 4-inch. So once we did that, we made 4 inches, and then actually 5 inches, 1 inch of soil, ground soil, and then we paved it. So this area was paved and gave it more structural integrity as far as compaction. Because then with the asphalt, you're basically at 100% compaction. So, and then we put the rail system in. So depending on the type of soil, we'll come up and take a look and make some recommendation for how we could achieve the intent. So Chuck, go ahead and ask your question, sir.
Oh yeah, that's pretty neat presentation. Thank you. I guess I had a couple questions about like the type of cable that's being used in there. Is it
Sure.
different from the type of cable you would use in a conduit system underground?
No, it's exactly the same talk. So there are 2 major type of cables, underground cables, utilities. Either it's called EPR, which is basically a plastic cover, or it's called cross-linked poly. So this system is produced by the largest cable manufacturer in U.S. called Southwire out of Georgia.
Yeah.
Southwire offers CIC, and depending on what the utility spec for cables are, that's what they put in there. California utilities, some of them use cross-linked poly, some use EPR, but EPR, I think, just in my experience, generally performs better. It's exactly the same cable that you would put in an underground system.
And right. Rudy, the CIC system is very speedy for putting into place. I believe your system is like 2 to 3 times faster to install.
Yeah, CIC is really was made for providing a cheap underground solution. What the experience with CIC is, once you install it, it's difficult to work through it. I mean, pulling cable in and out, movement in the ground, things that happen. So as a utility engineer, there are different perspectives on that. Some people don't like it. Some people have, typically everything when they're new, they're great. It's really thinking about what happens 10 years down the line. And one thing with the CIC has been around for decades. The old CIC was metallic, and when they laid that in, they used to put a lot of angles into it. So when later on, when you had a failure of cable, they couldn't pull the cable out. So it became a major issue. So a lot of utilities banned use of CIC. Southwire, a few years back, designed this new CIC with the high molecular plastic conduit, which performs a lot better, and it's not as easy to bend it. So they can't put a lot of, unusual angles to it. So in the longevity of the system, you're able to pull cable in and out. But in general, again, one of the benefits that I feel this concept provides is that visibility. As an underground engineer, we used to have either even PVC pipes or CIC. You have no visibility to what's happening to your system. I have had issues where I had a collapsed duct bank, um, and we didn't know anything about it. And then we went to pull cable and we couldn't do anything. And everything has to be dug up in emergency and dealt with in that manner. So I think from a safety perspective, I mean, it's just to me, you see everything. There's no one is going to dig this up by mistake. I mean, it's got high voltage signs all over it. If they dig it up, then they weren't paying attention. So,
So in the case where it's placed under the road or buried
yeah,
10
yeah,
feet down,
yeah.
is there a requirement for indicators that there's a buried line there?
Typically, you're going to see an system like this, and then you see it going down. So, yes, there's going to be markings. We snap the concrete, but the point being that you're going to see ground level on both sides of this. So, you're going to see ground level, and then it goes, dips down, and then comes up after whatever it is it crosses.
Mm.
So, somebody, I mean, if, obviously I'm not saying 100% of the time, but if somebody's looking at that and you see the marking, it's kind of pretty obvious that that's what's going in and out, especially with the stamped concrete on top.
Yeah, and Rudy, up here, we have a regulation at this moment in time that, as
Yeah,
you say, these regulations came from ancient times,
yeah.
dinosaur times, often, and not accounting for these new technologies.
Well,
So,
this needs to be, yeah, yeah,
uh,
open to
yeah,
this.
so I
Yeah,
would imagine that it would not, with California's acceptance of this and them getting the changes in their code that you were speaking to before,
right.
that we won't have to take it underground at all. Like initially, to overcome the legislative barriers that we've got here, the
Right.
code's like everything must be a minimum of 6 inches under. But we can actually shift the code when this is broadly accepted as a method of which it's on the way. Like from what Brad Curling was saying, who's the PG&E lead in the undergrounding area, or chief
He
engineer?
is responsible for the underground rebuild program, actually fire resilient system construction. So he's got overhead, underground, everything. But they obviously their goal, and I applaud their CEO, Miss Poppy, because she understands. And I tell you, I mean, in 1989, I took an engineering crew to Bermuda, and Bermuda was getting hit every year with hurricanes, 150, 160 mile per hour winds. They keep rebuilding their overhead, but no matter what they build, with the high winds, there was always issues. We went back and we rebuilt their system to pad mount on the ground. The key that the point I'm trying to make here is that if you want to manage external implication, it's best to get it underground. Now, if the
Yes.
underground is too expensive, this is a tool in the toolbox. This is not a silver bullet. This isn't meant to do everything an underground system does, but it is a tool where it makes sense to apply it. And there is
Mhm.
definitely a solution. Now, all of the utilities across US are reaching out to us. I've got calls from Detroit Edison, Hawaii, San Diego, Texas. I mean, every utility in the country is getting some kind of a challenge when it comes to underground. Even Con Edison in New York, um,
Yes.
and Eversource in New Hampshire. I mean,
And
but, yeah,
this is a good aspect, Rudy, like of what we already have going on here in King County, which is our local county.
yeah,
We have these King County road standards from 2007, and then it was amended to 2016. And those 2016 standards say undergrounding is strongly encouraged. And it makes particular note of urban areas because, as you were mentioning, the urban areas are much more expensive. So
right.
they're saying we want undergrounding, and we're going to say that even the most expensive areas we want undergrounding. So that a rural area like ours, we're so well set up, and the code is there. So we're hoping that our administrators and representatives say, yes, we're going to do what we put in place decade ago.
Well, one thing that I think you can also bring up, kind of a utility perspective that you guys can have in your back pocket. Utilities typically have built underground system in urban areas, so that is the cost that they know about. So when
Mm,
they always talk about undergrounding, they throw in the numbers that they have gotten from building in urban areas.
mm,
That is not the right number. So
no.
if you come in and saying, I'm in a rural area, I want to undergo and say, well, it's, X amount of dollars per month. Well, that's not exactly true. Because when you build in a um, highly, a big city, you have all kinds of traffic control. You have all kinds of other utilities that you have to work around. I built in Boston and New York. We had to dig with a spoon because there were so many different things in the ground. They had gas, steam, So I mean, everything you can think of for a city that's 300 years old, they are tucked into this little street of, 40 feet wide. So
Yeah.
when you go to a green field like your neighborhood,
Yeah.
undergrounding is not going to be as difficult. So that you just make
No.
sure that you push back on the cost element and make sure that they actually showing the right numbers.
Yes. And
Yeah. And since we're talking about costs, I did
mm,
have a couple more questions I wanted to
Yeah,
ask.
that's sure.
So specifically, and I'm talking about a pad mount environment because
Yeah.
that's what we would end up with in our locale.
Uh-huh.
Um, so I guess first off is this a less expensive solution to undergrounding than traditional undergrounding with pad mount vaults and transformers?
On average, we are, so I'm going to talk about averages because the reality is until you tell me no exact condition of the soil and where it's being built,
Right,
we're
right.
definitely cheaper than undergrounding. Now, if
Okay.
you are in hard grounds, we're probably 40% cheaper. If you're in soft grounds, we're at least 30% cheaper. The
Right,
thing that you're going to also take into consideration, we are 3 times faster to build than a typical underground because
mm,
we minimize the excavation. So
right.
our pilot here that I'm showing you, we from shovel to the ground, it took 3 weeks to build this system and finish the job. It
mm.
would have taken at least 3 months, 2.5 months to do a typical undergrounding for them.
What was the length of that installation? Do you know?
It was about
Huh.
0.89 months.
Oh, okay. And then so kind of another thing I'd like to point out, and even this for other people who may be watching
Yeah.
this is,
Uh-huh.
we have the pad mounts, I think the ones that you show were mounted right on top of the cable tray.
Yeah.
We have a clear zone requirement, so any
No,
obstructions have to be off of the road. So essentially it'd be interfacing with a vault and then T-tapping out to transformers to be placed off of the roadway.
yeah, that's not an
No,
issue. That we
no.
actually have a setup that we can do that. You're right. I mean, what we did was just to kind of show the concept. We would not build a system the way I showed you on that lab.
And
Okay.
Chuck,
Uh-huh.
to confirm, The code relating to clear zone regulations actually allows the undergrounding to occur on the right of way, and it does not have to come 10 foot off as an obstruction.
Right. I'm
A
talking about, you
curb,
can see in
as an example, a roadside curb, which is right next to the roadway, has a 6-inch rise, and the code allows poles to be, so I disagree with you completely with what you just said then.
So just to clarify, I'm talking about placement of the transformers, and you can see in the photo that he has up right now, the transformer sitting directly on top of that.
Yeah. No, this is
Um,
not, Chuck. You're right. This is not this is not gonna how we're gonna be doing it. But we actually does have different parts that we use for application. And it actually have a 45-degree that goes into the side, that allows it to connect and then come back out. So you know, depends on where you are. You could or use that type of thing. But if you happen to have any kind of restriction, if I'm going on the road here, like this particular example, there's no way I'm going to be building a pad right here. So on this application, the pads, let's see if I have a picture here that I could share with you. I don't think we did one. So here, for example, this is on the ground level that goes into a box. This is a subsurface box.
right.
And GLDS goes through there and connects in there. Now, this particular setup across from here is where they had a transformer pad mount, and then we tapped into that box and brought it up.
Right.
But we will design the system per the utility spec. So whatever that the local utilities requirements are, we can meet this. We can meet and do a design for them that's aligned with their spec and requirement for construction.
Right. Right.
We have all the different components.
Mm.
Yeah, that's interesting. So the type of vault that this connects to, is it different from a burial vault? I mean, obviously it's going to be shallower.
No, these are standard. If you want to look it up online, you could call prefabricated number 5 box is
Oh, okay, yeah.
yeah, you could kind of compare it to that. Let's see if
So
I can.
this,
Yeah.
because this is something that some of our local engineers have talked about, Rudy, and they've talked about doing 9-foot vaults. And we believe from my conversations with you, that isn't part of the picture with the GLDS.
You could do that. We can do whatever that's needed to be done. We can adjust our system. If they want to do a 9-foot vault, what we would do is we would build a GLDS up to 6 feet prior to get to that vault, and then we would excavate, go down, and then bring the pipes into the side of that.
Yeah.
Side of it.
What I'm going for though is that I don't think there's a necessity with the GLDS system to have that kind of. I think they're referring to traditional undergrounding techniques, which require these huge vaults, and they were. My conversation with Brad Curling too. He said, we never go more than 30 inches or 36 inches, even with traditional undergrounding, whereas our local people were saying 9 foot. So he said the only thing I could ever see that happening with would be if you had to go under a creek. So,
Some experience I have from working at the airport with the vaults is they have to be big enough and adequate enough that you can pull cable in and out, and you can get inside there and make up T-taps. And people may have different rules. I know the state of Washington and the electrical code have rules as to how big those vaults need to be. So that's all information that's available. But I mean, someone saying they need a 9-foot vault, I think that would definitely depend on like you're saying, where it is and what you're talking about. So, but those numbers are out there and available.
Yeah, yeah.
yeah, and another key question that Chuck brought up, which I thought was a good one, Rudy, was talking about the connection points with, we have a lot of long private driveways on the island, and a lot of those will already have overhead lines, and the connection point with GLDS. I saw on the patent actually how they connect together. Like they literally just head in underground into that 45 that you're talking about, I
Yeah.
imagine. Is that roughly correct?
Um, well, yeah, I believe so. I mean, you know,
I think you can correct me if I'm wrong in this, but that would be like you'd go from underground 90 up a pole and hit a pole mount transformer. I think that's usually how that's
we
done
could
with.
do all kinds of things. So, I mean, I'm gonna just show here. I mean, I don't know if I can actually show this since you're recording it because it's just some patent stuff that, but we have components to that will allow us to do all of that. We have to be able to adjust and attach to and connect to any kind of distribution system. So we have a riser that we use for. Let me just see if I can share this with you. Where's my sharing screen?
It's basically a very flexible system.
Oh yeah.
Can you?
There we
Okay.
go.
Yeah.
And
So this is basically connects to the GLDS, narrows up, goes up the pole. I have another unit that, if I may, just so it's all different drawings that we have. This is a conversion from ground level to go below ground. So this allows the deviation on the elevation. 6 inches below is the bottom. So, you have a bit of a cover. We actually redesigned this to, there were some concerns about structurally this area being too shallow and, over time erosion could expose it. So I've actually just modified this design to make it more square. Um, so this is a new concept. It's not a silver bullet. We continue to
Yeah.
enhance with our learnings. Our goal is to be able to provide, the best system that we can. Being a utility engineer, I am, well aware of some of the challenges, and I understand the dynamics. I understand the internal challenges, um, and the reality is that we just gotta be kind of gonna work collectively to address these things and work through it. So
yeah, that it was wonderful having the conversations with Brad, and he was talking about that the industry, it's typical to have these benchmarking, conferencing, uh, events where people from all over come together and find the highest, what's the best technology that's offered at this moment. And I just wanted to run through a couple of the numbers with California. Like I know that the goal was like 10,000 miles undergrounded. Is that
yeah,
right, Rudy?
10,000 miles. They wanted to get to 1,000 miles a year. The regulators here didn't approve their request. They went down to 350. But I really feel like the CEO at PG&E understands the challenge, and I think she's doing everything she can to do the right thing. Whether she's going to get funded through the rate base or she's going to find a cheaper solution to help execute the intent. Uh,
Mm,
I'm, I don't know. I don't believe she's very technical, but I think she has the right mindset. She understands the challenge ahead, and she understands that all you need is one bad event that could destroy your company, bankrupt your
yeah,
company. They've already
big,
gone through that.
big
So
time, which
I
is
think she's
exactly
being
what happened.
mindful of that. So
Yeah,
I
and
very highly.
all the industry news that I'm reading, everything is oriented towards undergrounding. It's not just the cost of the actual infrastructure being replaced many times. We're very used to storms here on a large scale. We have
Oh,
80 and 90 mile per hour winds is what it used to be, and in a future of significant shifts. We've got massive threat in that area, and that's on the island. Even though wildfires, where people are very familiar with it because of the California experience, and they know, even in Lahaina, Hawaii, which has a subtropical wet climate,
Right.
wildfires destroyed the place. So,
Well, we've had wildfires in Texas. We've had wildfire in Colorado. 2 years ago, we had wildfire in New Brunswick. Who the hell would think we'd have a fire in
yeah,
New Brunswick? I mean, that's like, coming from Boston, I mean, that was like always wet and cold. And,
yes. So
it's
we're
not
in
like they
a,
have 8 months of summer like we do, or 8 months of, no rain in California. Things dry out completely. But, this is a challenge that we have to stay. Australia is dealing with it. We have some implications in Europe such events have happened. But anyhow, so this particular, what I'm showing you is our new design for the elevation change. But as you can see here, Chuck, we made this 90-degree angle to prevent from the original design that was more of a slope. This will eliminate the erosion issue because it'll be structurally, it gives you the same change in elevation, but it keeps everything square. So when you cover this side, which is to be below ground, it's not gonna have any structural implication over time. So anyway.
And Rudy, just quickly on a couple of the key points that I've been sharing widely. We've got almost 1,000 signatures on a petition to do a feasibility study for undergrounding, which is 10% of our island population. So it's very strongly supported. And two key things are the comment by PG&E, lowest long-term 9% wildfire risk reduction. So the lowest cost per customer, we've spoken to that significantly already, but some of the numbers that I've been told by people in the industry here and connecting with PG&E, I've heard 2 million per mile for overhead, and as you say, it's averages, and 2.2 million for on grounding.
Yes, we are very close. My goal is, if we go in the direction we're going, I'm going to be cheaper than overhead. We
Yes.
are right now, we use a technology called thermoforming. It's very time consuming. I don't have enough orders to transition to extrusion or injection. If I can go to extrusion, the material costs will go down by 25-30%.
Yeah.
My goal is to get to 1.75 mil per mile at the max. Right now on the pilot, we are about $150 per mile for material and $175 for labor. So we're around $325 total installed cost. I'm cautiously optimistic I could reduce that by 20% at least.
Yes.
And
My goal is also to keep the stuff made in US. If I was to go to China, I could probably save even more, but I'm an advocate of building our own in this country, and I'm going to try to do that as long as I can to keep everything right here in our country with our own workers and rather than giving our business to somebody else. So, but again, in the interest of profit, I mean, in fact, people have asked me, why don't you go to China? I mean, I prefer not to. I'm cutting off China and everything that they do for us and everything that they built, but I want to watch after my own first.
And we were talking, you and I, about that the current trays are like 16 inches wide, I believe. I'm pulling
No, they're 24 inches. They're actually
24.
23 and 7/8. They're 5 inch in height.
Right.
And right now, because I'm doing thermoforming, my longest part is 6 feet. Ultimately, if I go to extrusion or injection molding, I could go to 10-foot parts. We're trying to ensure that we are aligned with all of the requirement with regards to OSHA, as far as weight that a worker could carry. We are very conscientious of the regulation, and we always want to try to comply with everything because that just makes things a little bit easier. One thing that's beneficial is the governor in the state of California and his directive committee that's responsible for more or less monitoring the activities with the utilities, has written a letter for us to be considered as a legitimate solution. So that to me is
Wonderful, wonderful.
it's a good you know I just think that we need to be open. Whether things work or don't work, I mean, just try it out. I mean, right now I have a pilot that's getting started with Southern California. We got an tribal land issue in San Diego, which they're not allowed to dig up the sacred ground. So this would really be the only other solution if they want to get rid of the overhead system. And then I've got a pilot going on with Detroit Edison that potentially gonna, all these utilities, they get build a couple 100 feet in their labs and, pilot location. That's kind of the first step. They kind of learn from it. One thing, Jenny, that you can advise your local utilities that this product is right now sitting with EPRI, EPRI. They are a research entity. They are completely independent. They are a nonprofit, and they are doing everything they can to provide an objective view of the pros and cons of the system and where it makes sense to use it. I tell you, one thing they told me the other day, they said, really, this is the greatest invention in 40 years for undergrounding because what they have been seeing is basically boring underground, digging stuff, and having an option for the right application is always beneficial to our industry. So
yeah, I think that this could be a really great tool in the toolbox. I'm thinking of questions involving kind of regulatory approval of this, especially in your state. Because I know most of the electrical installations we do are subject to National Electrical Code, and then they're also superseded by the state of Washington, which will adopt the code every 3 years, I believe, and modify things they don't like about it or add things they do like. So how do you see this proceeding through that kind of regulation?
So our testing at EPRI is going to most likely be finished by end of September. They're going to be putting out a report. As a part of their evaluation, they have an undergrounding committee that consists of a number of different large utilities that have underground systems. And that report is already looking into alignment with National Electric Safety Code, National Electric Code. And what they've seen so far is fundamentally it meets that requirement. Once we have the report, we're going to basically get some advocacy with the joining utilities to get to National Electric Safety Code and get that rule modified. Give you an example, Chuck. So right now, if you're building, like I've built a lot of electric systems for high rises. When you go into a high rise, I'm just picking a structure, right? John Hancock building 62 floors in Boston. I helped build the vaults there. We run 13.8 kV lines up the pole. We call it primary riser. So every 10 floor had a transformer room, and they converted that for distribution for the 10 floors. So every 10 floor has a vault with transformers. All of that system is basically it's got a 2-inch concrete envelope around it. It's exposed in the parking lot. It's exposed within the walls of if you go to the utility closets. So we're already doing it. They're already encasing 2-inch concrete envelopes around electric systems that are running on roofs and outside of the buildings. So it's just a matter of, majority of the reasoning from the 60s to have this was really to ensure that every utility had this space inside of this, the area that we're so electric is between 32 to 42 inches, sort line is usually all the way down, 8 to 9 feet down, gas. So they're just trying to, it more was really about securing the various utilities and preventing it. Now, did somebody think of, hey, I can use a synthetic rock to put this on the ground level? No, and we're not proposing this to be built in an urban area. The problem is that how these things were perceived and how these regulation and requirements were built was for certain application. Nobody thought, hey, if I was going to underground in suburbs, do I need to comply with the same requirement I do in an urban area with 2 million people living, or what?
Yeah.
That process was not there because it was automatically understood that if I go out here, I'm going to build overhead.
Mm.
So it just, to me, it just needs to be revisited. But to your point, once we have this report from a third party, entity, it's very credible, EPRI, then I think we can go there and it's not biased. Hey, this guy who invented this obviously thinks it's a good idea, but who else thinks it's a good idea, right? So we might get
Well,
that.
I know PG&E California think it's a good idea, Rudy, and Brad is basically they're putting out in their marketing that by 2025 this is going to be. So they're very
That's the
confident.
goal. That's the
But
goal.
I'm curious.
Yeah.
I'm
And
curious.
Louis, we just talked to Detroit, and they're got some other things. I'm sorry, Chuck. Go ahead.
Oh,
You,
I was just going to say,
oh,
I'm
no.
curious. I'm curious to see how PG&E uses this, as it gets more widely adopted. If they're using it as a cost saving measure, or if they're using it as a way to get around things like hard soil, contaminated soil, but if they're sticking with the more traditional methods of undergrounding.
Well,
Because
I
I
can tell
see
you
value
right
in.
now. I'm sorry. Didn't let you finish. My
Oh no,
apologies.
go ahead. I'm done. Yeah, that's all. I
So,
just
so
curious
they
to see
are gonna. There's several things, right? So they have to get. They obviously looking for cost, cost aspect of it, but they're also looking at speed because that's something you can't. If you're doing volume, speed is very important. If I'm gonna do 1,000 miles in a company, I've never even done more than 100 miles a year, and I want to do tenfold. Well, if I'm doing it the same way I've been doing it, it's going to be very, very challenging to get to that volume. Maybe you double it, maybe you triple it, but doing 10x, that is so you have to come up with new ways. So the point being that this system, there is absolutely no way that you would have an electrical arc with this system. If
mm-hmm.
that's your goal, and you want to make sure that your lines will never going to cause a fire, well, this is your way because it's not.
Mm.
It's in
And
fact, the point is you have multi-layer system, fully insulated cable inside of a rock. I mean, unless somebody's trying to sabotage you and cut through it, but you're not going to cause the arc. So that is the goal. And every utility may have its own, challenges and goals. But for them, if they can do it faster and cheaper, then they're going to apply it as many places as they can. Because
yeah, that was the strong message given to me by Brad, that they're when they do stuff like hardening of the overhead line systems, that's only a on the way to undergrounding and on grounding is absolutely the way forward
no.
for
Well,
them.
overhead, the thing is that we know from our experience in the industry, no matter what you put on the overhead, how strong, you look at
Yep,
Florida. I mean, if you look at Florida, they got these steel structures, right? They
yep,
got these huge, huge wires. Guess what? Yes, they have reduced the events, but when you get a 150-mile-per-hour hurricane, they have problems. They have outages. So it's really a reduction in risk, but it's not eliminating. Eliminating the risk is just taking that fundamentally, take those external implications away from
yes.
it potentially affecting your system. So
Precisely. And a really big point to make, it's not just the cost of putting in the infrastructure, but the kind of costs that took PG&E to bankruptcy, which was being sued
well,
on
yeah.
many levels. And in particular, there's more, what a lot of the industry insiders are saying is there's huge potential for suing for just having your electricity
Well,
down.
that's just California. But I want to just kind of reiterate how Chuck is looking at this is the right way. Don't forget about what PG&E is doing. I mean, you're not PG&E. You don't have the same challenges. Your utilities haven't gone through the same kind of issues. Is this a right tool to be in your toolbox? And that's, I mean, potentially you can be a pilot location where they can try it out. If they like it, they can expand it. They don't like it, at least, you address your concerns as it relates to the vegetation in your area. There's
Yeah.
still things that we're still learning. This is not
Yeah.
a mature concept. I want to go on record and just call it like it is. I'm an engineer. I want to make sure I'm solving a problem. And certainly, yes, I want to monetize it, but I don't want to monetize it because I'm selling goods. I want to monetize it because I solved the problem.
Yeah.
And one of the things, Chuck, that we still don't have enough knowledge and experience for, well, we have knowledge, but not enough experience, is how do you maintain it? What happens when it things breaks? What happens in something bad? How do you fix it? So we have installed 200 feet just about a month ago at Livermore site. And that's what PG&E construction team is going to be doing. They're going to beat the crap out of this. They're going to break it. They're going to cut the cable. They're going to cause a fault. They're going to do all kinds of things to understand all the different parameters. So that's an information that still is being evolved and we're learning. So it's,
Mm.
but again, I would say that it's something that utilities should consider. I mean, the only way you're going to learn is you try it. And you don't have to do a lot of it. You do a couple thousand feet, you do half a mile, you do 200
Yeah.
feet, and then you
Well,
can make your own, input into what your engineers think about it and then go from there.
it's such a very exciting technology, and I'm so grateful, Rudy, for the time that you've given us today. In particular, on our island, we have issues also where if it's moved off the right of way, which is what this regulation push
Yeah,
is doing, we've got eminent domain issues. There's eminent domain being done in court right now. Uh,
yeah,
and so all of those issues go away because it can stay on the
sure.
right of way and can be
Well,
undergrounded.
this definitely can stay that. This definitely can
Yeah.
there. And one of the things that you have to also think about, if you put the system in, you don't have to worry about, there are utilities in this country that are spending millions of dollars in vegetation clearing
Yes.
every year, every 3 years, whether they have a cyclic program or whether they have a spotted, objective program.
Yes.
Utilities patrol the circuit and pick the trees they have to do every single year. Some
Yeah.
people say,
We
hey, we're
we
going to
are.
every 3 years. But
Yeah.
we should put
That's
this in.
huge for
Yeah,
us.
that's
We are.
expense dollars. I mean, it's the
Oh, it's
benefit of the
huge.
utility, which always looking to reduce expense dollars because they cannot recover the expenses. They're only
Yes.
making
Yeah.
money on their capital investment.
And it's typical for us to have a cherry picker,
Yeah.
chipper, and at least a dozen people in flagging, and they come on and off our island. I'd say it's more than millions. It's a massive infrastructure cost.
Well,
So
an example, PG&E's, I think, is about 300 million a year, every single year, 300
yeah,
million
yeah, and
vegetation. I
and
mean, even yeah,
the
yes.
aesthetic aspects, which aren't often brought up, but are really, really important to people who live on our island and love our landscape and our trees. Like we've got these awful, like cutout trees where, they're topped, they're chopped
Yeah, they do
out.
what's called a reliability clearing. They could have a 10-foot span and then they top them off on top.
Yeah.
Chuck, I know you have, I can tell, and I saw your email. I think you have a lot of knowledge in this space and just generally understand fundamentally some of the challenges. So, what else? Other question. If you hang up, please feel free to email me. If something comes up, you say, I wanted this or that, don't hesitate to throw in your thoughts. To
Yeah, no,
me,
thanks so much for your presentation here. This has been really informative. I appreciate it. Thank you.
no, and
Yeah.
it's all about diversity and inclusion. If we're gonna get better, is I need to be listening to people, even though that you may not be the expert in whatever, but you're a smart man, and you never know where good ideas come from. So if you see something that you even think we could do that would help our system, I would love to hear from you, or Jenny from you. I mean, I'm open to any questions or perspective, even if you see something, have you thought about doing it maybe this way? So let me
Yeah.
know.
Well, we have a lot of smart people on the island, a huge amount. And Chuck, I'm very grateful for your contribution today and making the time. And Rudy, I think we should probably finish up so that we don't
Yeah,
go over an hour. But
yeah.
Rudy, You're awesome. Thank you for
No,
what you're
thank you. No, I hope I can be of some help and support to solve some challenges you're dealing with. Please feel free to reach out and let me know.
Thank you.
You're
We
welcome.
will. Thank you so much. Have a
Take
good
care.
one.
Good to meet you, sir. Bye-bye.
Bye-bye. There.